What's up to you all matriculants? This is your favorite show, the best learning show ever. It is Learn Extra Live, where we learn more and learn extra. My name is AB Abram, and I'm joined by Lee. How are you, Lee?
Hi, I'm great. It's good to be back again.
Oh yes, you know, it's Monday. It has to be maths, and we have to learn. Talking about learning, there's a joke that's going to be coming later on the show. So, mindset is keep it tuned in because Lee's going to give us a joke later on the show. So, hope you're ready about that. But talking about serious stuff, what are we doing today?
We are working on sigma notation, which, as I said last week, is sort of connected. Well, is not sort of, it is connected to sequences and series. And so we're going to spend some time on it, and I'm going to try and do some of the things we didn't get to last week as well.
Awesome. So what you need to do is to go to facebook.com/learnextra, like that page. But if you've already liked the page, share it with your friends, your group mates, your street mates, everybody that you know, and say, let's learn more on mindset. Post your questions in there and help one another. That's the whole aim. Otherwise, join us on Twitter. Follow us at LearnExtra. I'll be taking some of your tweets later on the show. And lastly, download your notes all for free on learn.mindset.co.za. But for now, Lee's going to be telling us more about what we're going to be doing in this lesson and the challenge question.
Definitely. Just remember to send us some questions if you want to for the third part of the show.
Exactly.
Great. Let's have a look. Now, as I said, we're working on sigma notation today. And let's just get to the next page. We revise the use of sigma notation, and we revise the use of sigma notation in the use of sequences and series. Right, so let's have a look at how we go about that. Now, first of all, the challenge question. And the challenge question is very nice. It's just something different. We'll come back to it later. It says, write the series below in sigma notation. Just a reminder is, remember, series just means that we are adding the terms together. We discussed this last week. And sequence would be that there's a comma between each of the terms. So I'm using the word series because I'm adding the terms together. So have a look at that. See if you can engage with it, and we'll discuss it later on in the show. But let's get going and revise a little bit of theory, and then we'll move straight into the questions. Right, now, last week we did look at this table, but only to a certain portion of the table. We did not get to our convergence. So that's what we're going to deal with today. There are two types, well, not two, there's several, but there are two main kinds that we're interested in. We're interested in a convergent sequence and a divergent sequence. And the divergent just means that as we go, the terms are getting bigger and bigger, either positively or negatively. And so if I sum them, I would get an enormous answer, either plus infinity or minus infinity. Convergent is what we're interested in because here we actually have formulas that work for us. And the first one here on the formula sheet says R lies from -1 to 1. So if our ratio is a proper fraction, positive or negative, then the series will converge. Converge, as I always explain to my students, is like when you go on a diet and first week you lose 1 kilo, the next week you lose half a kilo, and slowly you converge on your ideal weight. And so you get to a point where you can't go any thinner and you can't get any further. There are lots of other examples we can use, but let's think about a half as an R value. If we had half as an R value and we started our sequence at 8, well, the next term would be 8 times a half, which would be 4. Then the next one would be 4 times a half, which would be 2. And the next one will be 2 times a half, which is 1. So you notice that the terms are going 8, 4, 2, 1, a half. So they're getting smaller and smaller. So obviously, as I add them up, my sum will start slowing down. But we're going to spend some time on that just now. And then, of course, the sum to infinity formula, which is the one over here, where it says the sum to infinity is A, where remember A stands for the first term, and R for the ratio, and we're also going to get to work with that one. But the main bit of this work today is sigma notation. Now you'll see I've written it over there, and I just want to unpack it a bit. This sign, the sigma, means sum. So it's telling me sum from this number to this number, the formula that is put over there. So it's quite important to know. So if I've got a sigma, say, with R equals 1, say, and over here I've got 4, then I'm telling you to start with whatever this formula is at r equals 1. But then I would go to r equals 2, r equals 3, and r equals 4. And at that stage, I would stop, because that's where I must stop. It says to that. Right, so let's look at some questions. I think they make more sense once you start looking at them. Right, question 1 says, calculate the sum from k equals 4 to 6 of that particular formula. Now, as I explained to you, it's telling me to start at k equals 4. So I would go along and I'd say 3 to the 4 minus 2. And then to that, I would add 3 to the 5 minus 2. Because remember, I would start with the k equals 4. Then the next one up would be k equals 5. And then the last one I would put in here is when k equals 6, and that would be 3 to the 6 minus 2. Now, if I look at that, I've started at 4 and I've ended at 6. And let's work it out. So this pink one over here will become 3 squared. The yellow one will become 3 cubed. And the orange one will become 3 to the 4. Right, now these are numbers we can actually just work out. So let's just slide this down a bit. 3 squared is 9. 3 cubed is 27. And 3 to the 4 is 81. And if we add those up, we get 117. Now, that is fine if I know it starts at a relatively easy number and it ends quite soon. Then there's nothing wrong with doing just what I did, where I go along, I generate the terms, substituting one by one. Before we move off this, I want to throw a little aside into this picture. What would happen if I had something like this? Now, if you look at that one, it says sum from 1 to 3, the number 4. So effectively, this is my formula. Now, do we have a k to substitute in? And the answer is no, we don't. So if I put in k equals 1, there's nothing to put it into, so my answer would be 4. If I put in k equals 2, again, there's no k to put it into, so the answer is still 4. And if I put k equals 3, it's also 4 because there's no number to put in there. So in actual fact, this would be 4 plus 4 plus 4, which would give me 12. And again, it's a nice example because it's short and sweet. We're starting at 1, we're ending at 3. We're starting at 4, and we're ending at 6. They're very, very easy to work with when you get such a short selection. So remember, the sigma sign is effectively a sum. So in actual fact, this thing here means sum. So we're going to use them interchangeably as we work through the questions. Right, let's have a quick look at the next one. And this one says calculate, and this time it's a little bit different. You can see I'm starting at k equals 0, and I'm ending at k equals 15. For the purposes of this question, I could have said k equals 0 and k equals 115. Then you would definitely say to me, there's no way, Lee, I'm going to work these all out and add them up. K equals 0 to k equals 15, you might be tempted, but it's not a good idea because you would be generating, in this case, actually 16 terms. But I will discuss that with you in a little while. So let's have a look what we would do. Because we know the sigma sign actually means sum, let's have a look how these terms will look. So if I take k equals 0, which is my first value for k, it will be 10 times 0 plus 3, so the answer would just be 3. Then if I took k equals 1, and I put it in there, 10 times 1 plus 3 is 13. If I put in k equals 2, 10 times 2 is 20, plus 3 is 23. And I could keep on doing this till I got to my 15th one, which is k equals 15, because that was the last one. And I could then say 10 times 15, which is 150, plus 3, which is 153. Now you can see that if I was going to work out all those terms, the exam could be finished and we could still be working it out. Not such a good idea. So let's go over here and see what we're going to do now. Now what I would ask myself next is, what kind of sequence is this? So remember how we do it? We have a look and we say, well, what's happening from 3 to 13? Well, we are adding 10. What's happening from 13 to 23? Well, I'm again adding 10. And so on and so forth, but you'll see that if you had worked out, say, one more, it still would be adding 10. And so I can be sure that this is an arithmetic sequence where my A value is 3, my difference is 10. And now comes the exciting part, because after doing that, I've also got to find out how many terms in the sequence. Now, be very careful with this. Let's make it smaller, because when you make things smaller, it's always easier to understand. Let's go back to that one we had earlier on, and let's say if I had k equals 0 to say 3, and I was starting at, well, let's make it easy. Let's just make it 3 to the k. Well, if k is 0, the first term would be 3 to the 0. The next one would be 3 to the 1. The next one would be 3 squared. The next one would be 3 cubed. How many terms do we have? Well, we have 1, 2, 3, 4 terms. So if we look at stopping at 3, but I'm saying there are 4 terms. Now that makes sense, because if I'd started it at 1, I would have had 1, 2, 3. I would have had 3 terms. But now I'm starting it at 0, so 0, 1, 2, 3. So in actual fact, this one I've just put up with a 15 has 16 terms. Now, a good rule of thumb that you can always use to get yourself out of trouble is the following. You can always say, take the top number, subtract the bottom number, and add 1. So if I do that, I've got 15 minus 0, which is 15, plus 1 is 16. So I know that my n would be 16. Let's just check it on this one. Does it work? Well, yes, I would say the top number is 3. I'd subtract the bottom number, and then I'd add 1. And if I do that, I get 4. And were there 4 terms? Yes, there were. Right, let's just take this bit off, because it's got nothing to do with the question. It was just a way of explaining why we're getting that extra term. So a good rule is to always say top number minus bottom number plus 1. Another way to do it is to say it started at 4 and went to 7. Well, you say to yourself, all right, there would have normally been 7 terms had it started at 1, but I haven't got 1, 2, 3 there. I'm starting at 4, so there would actually be 4 to 7. So it would be 3 off the 7, so it would be 4 terms. But I still think it's easier to go 7 minus 4 is 3 plus 1 is 4. Simple, easy, and you won't go wrong. So I think it's a good plan. Right, so once we're here, we want to sum 16 terms. Now, last week, remember, we talked about the formulas. And the formula for a sum of an arithmetic is n over 2, 2a plus n minus 1d. And we're now going to substitute. So your n is 16 over 2. 2 times your a is 3. N was 16. And your difference is 10. And now it's a matter of just working that out. So let's just get a little higher so we can work with it. Right, so that's equal to 16 over 2 is 8. 2 times 3 is 6. And this is going to be 15 times 10. Right, which is equal to 8. And this is going to be 6 plus 150. Which means we have 8 times 156. Right, now that is equal to 8 sixes are 48, carry the 4, 44, carry the 4, and it's 1, 2, 4, 8. And there's my answer of that sigma notation. Now, of course, if you'd worked out all the terms and then sat and physically added them up, you still would have got that answer, but that's not the idea of this. It's just an alternate notation for us to see where we are going. So I hope that gives you a little taste, and I think we are just about due to go for a break. So I think we'll just let you think. Remember to check on your challenge question and see if you can see where we're heading with that question.
Exactly. It's already posted on facebook.com/learnextra, and also download your own notes. They are for free on learn.mindset.co.za. See you after the break. Welcome back, awesome matriculants. I hope you are practicing and doing what we're doing. Lee, I have a great response from Twitter also. There's someone who commented.
Oh,
when
good.
I hear that, Miss Terrace says, learn extra. Wow, I had a maths homework on sigma notation that I didn't know how to tackle, but within this 15 minutes, I already know what to do. Thanks a lot.
Oh, that's great news. I'm glad it's helping. That's very good news indeed.
Thank you, Mindsetters, and keep your questions coming because we love hearing
comments
from
also
you
good.
and help you, and comments too. Remember, the joke is still coming later on from me.
You're putting me under the spotlight here, guys.
Get ready.
Okay, great. Can I take it away?
Yes, please.
Great. I've got 3 really nice questions to discuss, actually 4 nice questions to discuss with you. I will try my best to do them all because last time I didn't get through them all, but there's some very nice bits and pieces in it. Let's look at this one. It says, calculate the sum of, and what's important here is they're talking about the sum to infinity. Now, you remember I said to you today we would work with this formula for sum to infinity. Now, believe it or not, and I'm sure your teachers have already done this with you, that formula comes off your normal SN formula, but I'm not going to get into that because that's just theory, and I'm sure you'd rather be doing questions than doing theory. So let's have a look at what it says there. It says sum from k equals 2 to infinity 8 times a half to the k plus 1. Now, before I even engage with it, if I say to you, start at 2 and end at infinity, how many terms am I going to have? Well, let's think about it. If I said start at 1 and end at infinity, how many terms would you have? Well, I'm sure you're all saying infinite amount of terms. So it doesn't matter if I'm going to infinity and I start at the second, k equals 2. No, because obviously the more, it's infinite. So if it's just like 1 or 2 missing, so it's still infinity. So it definitely is a sum to infinity, even though it does not start at 1. Right, so let's look at the question. Remember what the first thing I did is I worked out some terms to see what they looked like. So let's do that again. Just want to take this off so I've got some room to work alongside. Okay, let's start with the first one. If k equals 2, then the first term will be 8 times a half to the k plus 1, so it's 2 plus 1, which means I've got 8 a half to the third, to the 3. So that's going to become 8, and a half cubed is going to be 1/8. Well, what do we know about 8 times 1/8? It's equal to 1. So the very first term we've got here is 1. Now, if k is equal to 3, I've now got 8 1/2 to the 3 plus 1, which means I've got 8 a half to the power 4. Half to the power 4 is 1/16, and if I tidy that up, I'm going to get a half. So my next term is a half. One more term just to be sure where we are, so let's just get some space again. It's a nice thing about these boards, they really make erasing fun. Right, so if k is equal to, we've done 2, 3, this is now k equals 4. We have 8 times a half to the 4 plus 1. So it's 8 and a half to the power 5 is 1/32. That's over 1, so that goes once, and that goes 4 times, and my next term is a quarter. Now, we know it's a sum to infinity. So if it's a sum to infinity, can we get to the end of it? Well, hopefully you all realize there's not a chance, not a chance. Right, let's get that pen up there again. So we know it's going to continue forever. Now, remember what I said to you when I mentioned convergence earlier on. I said to you, when a sequence starts going smaller and smaller, I think I started at 8, then I went to 4, to 1/2. Well, this has gone 1/2, a quarter. So your terms are getting smaller and smaller. And so we know that we're not going to have a problem getting an actual answer. If it had gone 1, 2, 4, then obviously there's no point to summing it because we know it'll be infinite. If you're going to keep on adding bigger and bigger numbers, the answer will be infinite. That's what we call a divergent series. Now, this is convergent. They don't ask me that. That'll come up in one of the later questions. Now, the question I want to ask you, is this arithmetic or geometric? Well, if we look here, 1 to 1/2 would give me -1/2. 1/2 to a quarter give me -1/4. So it's definitely not arithmetic. But if I times this by a half, I will get a half. And if I times this by a half, I'll get a quarter. So I can safely say my R is equal to a half. Now, I gave it away by giving you this formula, but you know that the sum to infinity does not work for an arithmetic. It's actually going to be infinity or negative infinity, depending if the terms are getting bigger and smaller, because an arithmetic sequence will not converge. So this is definitely geometric. We know that the A is the first term, which was 1. We've got R, and we know we are looking at n equals infinity. Right, so all we would have to do now is use our formulas. So let's just pull this board up a bit. So we know that that is equal to, the sum to infinity is equal to A, which is 1, over 1 minus R, which is going to be 1, and that's going to be a half. And of course, we know that if we are dividing by a fraction, we can multiply by this one inverted. So the answer of this is going to be 2. Now, does this make sense that if I keep adding these terms, the answer will be 2? Well, let's look at it in a number line. That's the best way to see it. So let's pop a number line down there. Okay, that's 1 and that's 2. And the first thing I'm doing is I'm saying the first term was 1. So we went from here to here. Now I said to you, let's add on a half. Well, if you add on a half, we're going to end up there. So we had 1.5. Now, if I add on a quarter, I'm there, and I'm going to get 1 3/4. Now, if I add on the next term, which would be 1/8, I am going to get closer to this, but still not on top of it. So I think you can see from the number line, as I'm adding, the things are getting smaller and smaller and smaller, and so I'm never going to pass 2. So that's why I can safely say the sum to infinity is 2. Right, let's look at the next question. Right, the next one says, sum from k equals 1 to n, 6k minus 1 is equal to 320. And they ask you to find how many terms we added. Now, nothing is going to change. We're still going to generate some terms first of all. So let's do that. So over here, if I'm looking just at the sigma part, k equals 1 to n of 6k minus 1. If I put in k equals 1, I'm going to get 6 minus 1, which is 5. If I put in k equals 2, I'm going to get 6 times 2, which is 12, minus 1, which is 11. And if I put in k equals 3, I'm going to get 18 minus 1, which is 17. And I could work out a few more. I don't know what term n is. I suppose I could find it if I went and just called it 6n minus 1. But for the purposes of this exercise, it wouldn't really help us here. So what's happened? I've added 6 to get there. I've added 6 to get there. And so I can safely say this is an arithmetic sequence where my A is equal to 5, my D is equal to 6, N is missing, and I know that the sum of N terms is 320. Great, so now we're ready to work it out. Remember what I said to you, it's always a good idea to make a list of what you've got. Because then when you look at your formula, you can see how many knowns you've got, how many ones you haven't got. So we can see of the 4 things in the sum formula, we've got 3 of them, which is a very good situation to be in. So Sn equals n over 2, 2a plus n minus 1 d. Right, so let's go for it and look at it slowly. So we know that the answer of this is 320. We don't know what our n is. Our 2 times a will be 10. We don't know what n is, so we leave it alone. And our difference is 6. How many unknowns have we got in this equation? Well, I'm sure you can see that the only unknown is n. However, we can have an exciting n. It's going to have something different about it. Let's have a look what happens when I tidy up. Right, so I have 320 equals n over 2. Let's make this bracket look a little bit better. So we have 10 plus, and I'm going to times the 6 in here and the 6 in there. So I'm going to have 6n minus 6. Now, I don't like to work with fractions, and I'm sure you don't either. It just increases our chances of having a problem. So what I'm going to do is I'm going to times both sides of this equation by 2. So that 2 will take that one out. And I've now got 640 equals 10 minus 6 is going to be 4 plus 6n. Now, of course, you're saying, well, you didn't need to times by 2. Yes, you're quite right. I didn't need to because it would have divided nicely out. However, it doesn't always do that. So it's a good idea to rather eliminate that fraction, and then it makes it a bit easier for you. Right, let's move it up. So what have I done? Oh, yes, I've left off the n in front here. All right, so what I've got is 640 equals 4n plus 6n squared. Now, it's so nice because everything here is divisible by 2. So I can go 320 equals 2n plus 3n squared. So it didn't matter if I did a little scenic route, but I'm pretty sure that my arithmetic would be right. So now, because it's a quadratic, we know to bring everything to one side. And then we're going to do our favorite occupation, namely factorize. Now, if we look at this, we've got a 3n in the front and a 320 at the back. So I think 320 obvious possibilities would be 32 times 10. And don't go looking for hard ones, because often they are the simple ones. So it's usually something that's manageable. Of course, if all else fails, you can use your quadratic formula. But in actual fact, I would suggest look for the obvious first. And if I do that, I can say 0 equals, and I'm going to make it a trinomial factorization. So I've got 3n and n. I'll put the 10 there and the 32 there. That makes that a plus, and it makes that a minus. So n is equal to minus 32 over 3, or n equals 10. Now, what does n stand for? N stands for the number of terms. Can you have, whoops, I just went a little bit skew there. Can we have a number of term that is negative, first of all? I'm sure you haven't heard of a negative term before. Well, a negative number, yes, but not a term number. And we're certainly not going to have a fractional term either. So again, there would be a problem there. So I can safely say this one is not applicable, and this one's right. Now, the question I'm sure that is springing into your minds right this moment is there a time when you can get two answers? Yes, there most certainly is. So if my answers had worked out to be n equals 10 and n equals 5, well, both of them are possible. And when that happens, it's usually when your sequence is going across positive and negatives, and the terms counteract each other. So if there are whole numbers, then certainly you can have two answers for your sum. Right, so that's a nice question. We've answered it, and we've got the solution. Right, let's look at question 5. Now, this one says, given the geometric series 2 times 5 cubed plus 2 times 5 to the 4 plus 2 times 5 cubed, etc., show that the series converges. So, to check out for convergence, we need to find our ratio or our R value. Now, remember from last week, R is always determined by taking any two consecutive terms. So in this case, we've got term 1, 2, and 3, so we might as well take term 2, divide by term 1. So if we do that, we've got 2 times 5 to the 4, divided by 2 times 5 to the 5. The 2's divide into each other, and then from our exponential laws, we know that this will become 1 over 5, because there are 4 there and 5 down there, or you can go 5 to the minus 1, which is equal to 1/5. Now, what was the condition for convergence? We learned in the table just now that if R lies from minus 1 to plus 1, it converges. Well, is 1/5 between minus 1 and plus 1? Yes, it is. So we can safely say this series converges. Right, now it says calculate the sum to infinity of the series. Okay, so the sum to infinity, I'm going to work relatively quickly. We've already done one like that, so I'm going to go a little bit faster. So my A would have been, I think it's 2 times 5 cubed. Decided to make a mess on the board. Okay, it's 2 times 5 to the 5 over 1 minus 1/5. And we can tidy that up and work it out. I'm not going to do that because that's just donkey work. Important is this last part of the question, and that's where I want to get to. Then it says, calculate the sum of the first 8 terms correct to 2 decimal places. So they're giving me permission to use my calculator. And so in actual fact, I could have used my calculator here. So let's do it so we can speed up a bit. Remember that if we wanted to, we could rather write this as 2 times 5 to the 5 over 4/5. And of course, you could have done it normally, but I'm going to just bring the calculator up, and we're going to do it that way. So we've got 2 times 5 to the 5. Fraction button, oh dear, sorry, I'm getting very adventurous in my old age. Okay, 5 to the 5. And then I want to space bar down, I forgot about that, divide by 4/5. So fraction button 4 over 5 equals. That's my answer. And they said I could have to so many decimal places, so let's just do it. It's 7812.5. 7812.5. Right, now the next one asks me for the sum of 8 terms. Now last week we didn't work with the sum of a geometric, so it's a good opportunity to do that. So the sum of 8 terms, remembering that our R is 1/5, the best formula to use for that is going to be A, 1 minus R to the N over 1 minus R. Right, so let's get some space going. So it's equal to your A is 2 times 5 to the 5, 1 minus 1/5 to the 8, and that's 1 minus 1/5, which is 4/5, which we're going to stick in the calculator and get an answer. Okay, I'm going to be lazy and leave it there because I really think I'd rather finish the question than leave it halfway. So it now says to you, use your answers to B and C. So your answer of B is here, and this would have been your answer of C. To calculate this next one, now notice what they're doing. They're summing to infinity, but they're starting it from k equals 9. Now remember, the original started at k equals 1. So in actual fact, what they want you to see is the following, that the sum of this thing equals actually the sum to infinity of the original minus the sum of 8 terms starting at 1. And so you would take the answer of your sum to infinity, which is your 7812,5, and you'd subtract from it the answer you got for C, and you get the answer. But they help you a bit. So that just gives you an idea. I just wanted to rush that because I think it's an important skill that you've got over there. Let's hand over for a short break.
Thank you so much, Lee. Before we take that break, I have my joke for you. And it's about you.
Oh dear.
Well, my joke is from John. John says, you know what, that medium is a human calculator.
Now that's fine. I can handle that joke. I was a bit worried.
Well, Mindsetters, stay tuned for more learning and keep those questions coming. And remember to visit our website, our Facebook page, which is facebook.com/learnextra. Like the page and remember to take the challenge question that is posted there. For notes, it is learn.mindset.co.za. See you after the break. Welcome back, awesome matriculants. Now remember that learning is the only treasure that will follow its leader until the end. So if you're learning now, learning will always follow. It's more like education, something that you will never ever exchange it with anything. It's just a treasure that is so beautiful. So keep learning and know that your learning is yours. No one can take it away from you. Let's do the challenge.
True. My father used to always say, it's one thing that no one can ever take away from you.
So true. So it is a treasure that one must cherish and know that you've obtained it the right way, of course, by working hard. Now let's do the challenge question and see.
Right, I'm so pleased because I hear from the studio that there are lots of submissions that have come in.
And they're so cute in a way that Mindsetters have submitted pictures of what they were doing.
I think that's awesome. We did try and get them up, but we didn't have any luck. It was too short a break to post. We were going to put them up and discuss them. So well done for trying and coming up with answers.
Should one be right, I'll post it on the page.
Ah, good. Yeah. That's great. Right, if we look at this, write the series below in sigma notation. Now, first thing we must establish, just like we did before when we had the sigma notation, is what kind of series is this? Well, let's have a look. If I look at this, from moving from 2 to 4, I added on 2. From 4 to 7, I added on 3. From here to here, I added on 4. So it's not arithmetic. So right, what do we check for next? We check, is it geometric? So if we look at geometric, 4 divided by 2 would give me 2. 7 divided by 4 certainly does not give me 2. So it's not geometric. Not to panic, however, because last year you learned the quadratic series. And remember how that one worked. We first of all got the first difference, and then we went and we found a second difference. And I just want to get that yellow pen to work. And once the second difference was constant, we knew it was quadratic. Now, you've probably been shown a multitude of ways of doing this. So I'm going to actually show you what I normally use, and it has worked very well for me. There are formulas you can learn and stuff. But, you know, I'm not one for that. I just believe that if you're going to go and learn this complicated formula with all sorts of things in it, and I don't think it's on the formula sheet anymore. It used to be, but now I don't think it is. So really for me, it's let's find the most effective way to do it, and this is what it is. Now how it comes about is when we know something is quadratic, we know it will take the form of an squared plus bn plus c. So what I would do is I would generate terms. So term 1 would be a plus b plus c. Term 2 would be 4a plus 2b plus c. And term 3 would be 9a plus 3b plus c, and so on and so forth. Now, if I take the first difference here, 4a minus a is going to be 3a, and 2b minus b is going to be b. If I take the next one, I'm going to say 9 minus 4, so it's going to be 5a, and 3b minus 2b is b. Okay, so the last one is this second difference, and there I'm going to say 5a minus that is going to give me 2a. So what I deduce from this is the second difference is given by the formula 2a. This one is the first difference. It sounds like I'm stuttering, but I'm not. And this one over here is term 1. Now, all I need to do is remember those 3 little easy formulas. So let's go and show you with a question how that works. Going back to the question over here. If we look at it, remember what I said to you. I said the first thing we do is we start at the first difference, the second difference, which is 1. And we know that, and it does help if this pen registers, that 2a is equal to, and the difference on the second difference is 1. So my a is equal to a half. Right, now once I've got that, I know that the first difference is going to be, and I think I should use another color so we can see it. Let me just erase this, so that's out the way. Okay. We know that our first difference is going to be this number 2. So we know that 3a, what was it, 3a plus b, if I remember rightly, is equal to that first number, which was 2. But we have solved for a. We know that it's 3 times a half plus b equals 2. So now we've got b equals 2 minus 3 over 2. So b is equal to a half as well. Right, so we've got our a and our b value, and all we need now is our c. And remember what I said to you about that. We know that this first term is a plus b plus c. So a was a half, b is a half, and we need to find c, and if we do that, c is going to equal 1. So now we've got our a, our b, and our c. And what I've done is I've generated the term. So let's just go here. So I know that Tn is going to be a half n squared plus a half n plus 1. Now, that's all very well. It still isn't answering the question that we were asked. The question we were asked was to write in sigma notation. So now we know what the term looks like, or the formula looks like. We can start there. So we can say, right, I'm a sum. The formula I'm using is a half n squared plus a half n plus 1. And where am I going to start for n? And where am I going to end for n? So let's go back to the actual equation. And I can see, oops, I'm just going a little bit too fast here with my finger. There it is. I know that this would be my term 1, so that would be when it's 1, but I need to find out what number term that is. So what I'm going to do is I'm going to just clear space here. And what I'm going to do is work out what that term is. So I'm going to say term n is 46. Now remember, the term looked like this. It was a half n squared plus a half n plus 1 is 46. Now remember what I told you. It's never good to work with fractions. It makes it hard. So n squared plus n plus 2 is equal to 92. And so n squared plus n minus 90 equals 0, which means we can now factorize that very nicely. Just let me get a little bit more space over here. And we can say, right, that will equal, in factors, n and n, 9 and 10. And we're going to make that a plus and that a minus equals 0. So our n could equal 9, or our n can equal negative 10. Now, hopefully, you know that it can't be that one, because remember we discussed that a term can't be negative. So we know that our n is 9. So we can go back to our question now at the bottom, where we were starting to write it, and we can say start at 1, end at 9, and that's what we have to sum. So hopefully that's what came out in our actual things. We'll have a look just now and see. But well done to those of you that were brave and jumped in, boots and all. Right, let's go back to the previous questions, which we were doing earlier on. There was one more I wanted to discuss with you, and I'm glad we've got time to do it. I'm very pleased today because we've actually managed to, I think I've gone into the wrong thing here. Let me just go back up again. There it is. Okay. This question 6 is a lovely question too. And this is something they love to do with sigma notation. They almost mix arithmetic geometric, or maybe quadratic arithmetic. Why not? They can do what they like. So that's what they do in actual fact. So let's have a look at this. The first one here, I'm going to concentrate on the left-hand side. It tells me k equals 1, and I'm a sum to infinity the terms of 27 p to the k. So let's get that looking more like a normal thing without the sigma notation in it. Remember, our first step is always to generate some terms. So if k equals 1, the first term will be 27 p to the 1. The next term, if k is equal to 2, will be 27 p squared. The next one, 27 p cubed, etc. But they want me to sum to infinity. So that means it must be geometric. My a is going to be 27p. And my r, well, how do I get that? I take term 2, divide by term 1. And if I do that, I'm going to get p. So now I can go sum to infinity equals a, which is 27p, over 1 minus r, which is that. So the left-hand side is now very normal. It's just an expression. So let's go and see what the right-hand side starts to look like. So the right-hand side, let's change the pen so we're clear which is left and right. Says if t is 1 at the bottom to 12, and the terms are 24 minus 3t. All right, let's get ourselves some space. Right, we're going to generate some terms first of all. If t is equal to 1, the first term will be 24 minus 3, so it'll be 21. If t is equal to 2, it's 24 minus 6, so it'll be 18. And if t equals 3, it's 24 minus 9, which will be 15. And we can keep going. They say to the 12th term, I'm not going to even worry working out the 12th term because we've got formulas that do it for us. So what I have to do here is I have to work out the sum of 12. Is this arithmetic or geometric? Well, if I look here, I subtract 3. I subtract 3. It's definitely arithmetic. So it's n over 2, so it's 12 over 2. Remember the check? I say 12 minus 1 is 11, plus 1 is 12. So they're 12 terms. And our 2 times our a is going to be 2 times 21, plus n minus 1, which is 12 minus 1, times the difference, which is minus 3. Just a little something here. Remember to use your brackets, because if you just go minus 3 after a bracket, it could get confusing as to whether you're multiplying or you're subtracting. So rather just use your brackets to keep your places. So that's equal to 6. 2 times 21 is 42. Whoops, I'm squiggling a little bit fast. So let's just slow down a bit here. It's 42. And this one is going to be 11 times minus 3, which is minus 33. All right, so that's going to give me 6. And 42 minus 33 is 9. And that means we've got 54. Okay. Right, so now what did they tell me? They told me that the sum, so that oh, let me use the color so it doesn't get confusing. Back to the orange pen. Let's just go back to what our answer was. I think I do remember, but let's just make sure. It's 27p over 1 minus p equal to, and the yellow answer was 54. And now I'm sure you're thinking, oh, well, this is not bad. This is just a straightforward equation. Something where you're solving for the p. So where it was confusing, not bad at all. Right, so what are we going to do to solve this? We're going to times through by the denominator. So we're going to get 27p equals 54 times 1 minus p. So we have 27p equals, and the 54 is going to be distributed into the bracket. So it's 54 minus 54p. Right, tidying up a little bit more. We're going to bring the p's to one side. This is not quadratic, so we can keep p's on one side, numbers on the other. So we're going to have 27p plus 54p equals 54. And so I have 81p equals 54. To solve for p, I need to divide this side by 81 and this side by 81. And p is equal to, and now the good news is 27 will go into there twice, and 27 will go into there 3 times. So p is going to be 2/3. Isn't that just a beautiful little question? And I think it's nice because it's the mixture of the two together, which comes to a straightforward simplifying fraction kind of looking thing, which you then simplify. Now, I'm glad we've got a minute or two left. I want to go to the multiple choice, which are at the end here, and just look at a few of them that are quite interesting in the light of our challenge question. I'm not going to worry with number 1. I think it's going to be easy for you. 2, I'm sure is easy too. 3 is straightforward as well. Oh, no, 3 I want to discuss. What is the difference between the sum of the series where we close the bracket around it and we don't? Now, this is very important. It's like if you write sine 30 degrees plus 20 degrees and you don't put a bracket, then you're only signing the 30 and not the 20. You have to actually close it off if you're going to do the whole thing. So what I wanted you to do is to look at this question and to say, how will this look? Well, if n is 1, the first term would be 2 times 1 plus 3. Added to 2 times 2 plus 3. Added to 2 times 3 plus 3. Added to 2 times 4 plus 3. Added to 2 times 5 plus 3. So in actual fact, it would be 5 plus 7 plus 9 plus 11 plus 13. And we can work that out easy enough. It'll be 20, 40, 45, I think, the answer. Maybe I should be careful in case I'm a calculator again. I like that joke. It was a good one.
Yeah, maybe.
Right, the next one here, it's not like that. So what do we do with this one? Well, it says we must first do that, and then we must add 3. So the first term would be 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5, and then only would I add my 3. So that would give me 2 plus 4 plus 6 plus 8 plus 10, and then my 3. And so if we look at that, that's 10, 20, 30, 33. And you can see the answers are hugely different. 45 is not 33. So if I said, what is the difference in them? Well, the difference would be 12. And you go and select your multiple choice accordingly. Right, I think let's have one more engaged with a multiple choice. I won't probably work it through, but I'll start you off on it. Here's another one where they ask you to use sigma notation to represent that sequence for 28 terms. So that's quite a nice one because you don't have to worry about where you're ending, they tell you. So they're telling you exactly where to start and where to end. And what is your procedure? You've got to find out what a term would look like. So you ask yourself, is this arithmetic or geometric? 3, 6, 9, 12. Well, we've gone up by 3, up by 3, up by 3. It's arithmetic. So how does a term look for arithmetic sequence? It's Tn is A plus n minus 1d. The A is 3. The n we don't know. The difference is 3. So we have 3 plus 3n minus 3, which is good news. We're just going to get 3n. And we've done it. So I want you to realize it's a simple process if they ask you to write in sigma notation. Decide what kind of sequence it is, find it as a term, and then put it into the sigma. And yeah, I hope you've had a lot of fun and learnt a lot. That's very important. Let me pass over as we finish up.
Just quickly before we wrap it up, there's some mindsetters who are saying they're struggling with the arithmetic sequence formula. What is the best way of treating the formula?
The arithmetic sequence.
Yes.
Okay, so like a term or
Yes.
some term.
The term.
Okay, now what I would do, let's just find a bit of space here at the bottom. I always remember it like this. So if I say term 12, I know it's A plus, and there'll always be one less than the thing difference, so it's 11D. So that's how I would do it. So I just look at it. If it's term 764, well then it's A plus 763D. Okay, hopefully that helps. It just makes it easier than writing that n minus 1 is confusing.
Hopefully. But thank you so much.
Good.
I really appreciate working with you, Lee. And the
always
mindsetters
fun.
have enjoyed themselves.
Good.
Unfortunately, Mindsetters' time, is always against us, but I hope you enjoyed the show that we brought you. Keep learning, because when you stop learning, you stop breathing, you stop living. From us to you, we just want to say, keep learning, get our resources on learn.mindset.co.za. Otherwise, you're also on Facebook, on facebook.com/learnextra for all your help. Remember, the Mindset Help Desk is also there, helpdesk@mindset.co.za. For today, we just want to say, peace out, we love you.